All right, here we go. This is for the assignment radius of a cloud of gas that will collapse. You can see the two equations that I put up. The one for density is the one we're going to use. Let's see the first question. The gas is made of hydrogen. What is the mass of a hydrogen in kilograms? Okay, if you go to the files, oh my gosh, okay. Gotta back it up a little bit. All right, go to files, here we go. I'm clicking on fifth period. All right, go to files. And let's see, there's the data sheet right there. If I go to class materials, I'll see the data sheet again, plus the IB Physics resources option. So there's a PDF file that I'm using to get my notes from. So it's like a textbook. All right, and so here's the we go to go to the data book, and then I will find the mass of a proton. Make it a little bigger. Okay, so hydrogen, mostly made of protons. So I find the rest mass of a proton, and I can see it right here. 1.63, 10 to the minus 27. All right, and then I'm gonna go back to Teams, take a look at those questions. Let's see, get a student view of it here. All right, first question. The gas is made of hydrogen. What is the mass of the hydrogen in kilograms? Okay, I got that off the data sheet. 1.673, 10 to the minus 27 kilograms. Okay, if the gas of a cloud is in the shape of a sphere, what is the equation for the volume of the sphere? Okay, so I just imagined that the gas will be a cloud of gas, shape of a sphere. So I need to find the volume of the sphere, because you have to think of it as a basketball rather than a circle. So it'll be like 4/3 pi r cubed. Okay, let's see. Next question here. The density above is given in atoms per centimeter cubed. Knowing the mass of an atom for problem 1, and knowing how to convert centimeters cubed to meters cubed, find the density of the cloud of gas. Okay, so let's see. Here's the question. Take the density of interstellar gas in a cloud, 100 atoms of hydrogen per centimeter cubed. Okay, so it's got to be a problem, right? So it's got 100 atoms per centimeter cubed. Centimeter. All right, so we'll be able to convert that. Let's see. So there's per meter is 100 centimeters. So if we cube it, that's like meters cubed. All right, and also we want to, for every atom, there's one atom, it has a mass of 1.673 times 10 to the minus 27 kilograms. All right, so let me back it up a little bit. Okay, so 100 atoms, centimeter cubed. Convert to meters cubed, convert from atoms to kilograms, and you'll find the density. You'll find the density of the material here. Okay, and that's going to be answer to number 3. Using the density equation, find the radius of the gas. Okay, and so I'm going back to the density equation. density, mass over volume. Okay, so the density, it's going to be right there. But the density by mass over volume. So I got my density from problem number 3. The mass is given. It is 3 times 10 to the 33 kilograms. So my density from problem 3 is 3.0 times 10 to the 33 kilograms over the volume, which is 4/3 pi radius cubed. Okay, so I get the density from part 3. I plug it in there. I get the mass 3 times 10 to the 33 kilograms. My volume is 4/3 pi r cubed. I'm going to solve for r, so I have to find a cube root. Now, the cube root, let's give an example of cube roots. Now, let's say I have like 3 cubed. So it's like 3 times 3 times 3, 27. So the cubed root of 27 equals 3. Okay, it's a little different when you're finding the cube root of this one over here because you have to cube root some exponents. So let's say I ended up with 10 to the 12th, right? Something times 10 to the 12th. Well, I need to cube root the 10 to the 12th. If I don't have like the magic yellow calculator, I can just think of this like how many times does this thing get multiplied by itself? So it's like 10 to the 4th times 10 to the 4th times 10 to the 4th. Okay, that's going to be 10 to the 12th. So the cube root of 10 to the 12th equals 10 to the 4th. All right, so going back over here, where, density, we found it in problem number 3. Okay, the mass was given in the equation. Okay, the volume equation, 4/3 pi r cubed. That was actually, I think, question number 2. And so solve for r, and you should end up with a radius in meters. You should find r in meters. Okay, hopefully this will help.